a WikiVidi Documentaries production. Don't forget to like and subscribe. Enjoy. Sun. The Sun is the star at the center of the solar system. It is a nearly perfect sphere of hot plasma, with internal convective motion that generates a magnetic field via a dynamo process. It is by far the most important source of energy for life on Earth. Its diameter is about 1.39 million kilometers, i.e. 109 times that of Earth, and its mass is about 330,000 times that of Earth, accounting for about 99.86% of the total mass of the solar system. About 3/4 of the Sun's mass consists of hydrogen, the rest is mostly helium, with much smaller quantities of heavier elements, including oxygen, carbon, neon, and iron. The Sun is a G-type main sequence star based on its spectral class. As such, it is informally referred to as a yellow dwarf. It formed approximately 4.6 billion years ago from the gravitational collapse of matter within a region of a large molecular cloud. Most of this matter gathered in the center, whereas the rest flattened into an orbiting disk that became the solar system. The central mass became so hot and dense that it eventually initiated nuclear fusion in its core. It is thought that almost all stars form by this process. The Sun is roughly middle-aged. It has not changed dramatically for more than 4 billion years, and will remain fairly stable for more than another 5 billion years, after hydrogen fusion in its core has diminished to the point at which it is no longer in hydrostatic equilibrium. The core of the Sun will experience a marked increase in density and temperature while its outer layers expand to eventually become a red giant. It is calculated that the Sun will become sufficiently large to engulf the current orbits of Mercury and Venus, and render Earth uninhabitable. The enormous effect of the Sun on Earth has been recognized since prehistoric times, and the Sun has been regarded by some cultures as a deity. The synodic rotation of Earth and its orbit around the Sun are the basis of solar calendars, one of which is the predominant calendar in use today. Name and etymology. The English proper name Sun developed from Old English sunna and may be related to south. Cognates to English sun appear in other Germanic languages, including Old Frisian sunna, Sohn, Old Saxon sunna, Middle Dutch Sohn, Modern Dutch Zon, Old High German sunna, Modern German Sohn, Old Norse sunna, and Gothic sunno. All Germanic terms for the Sun stem from Proto-Germanic sunnan. The English weekday name Sunday stems from Old English and is ultimately a result of a Germanic interpretation of Latin dies solis, itself a translation of the Greek mu rho alpha lambda omicron upsilon. The Latin name for the Sun, Sol, is not common in general English language use. The adjectival form is the related word solar. The term Sol is also used by planetary astronomers to refer to the duration of a solar day on another planet, such as Mars. A mean Earth solar day is approximately 24 hours, whereas a mean Martian sol is 24 hours, 39 minutes, and 35.244 seconds. Religious aspects. Solar deities play a major role in many world religions and mythologies. The ancient Sumerians believed that the Sun was Utu, the god of justice, and twin brother of Inanna, the queen of heaven, who was identified as the planet Venus. Later, Utu was identified with the East Semitic god Shamash. Utu was regarded as a helper deity, who aided those in distress, and, in iconography, he is usually portrayed with a long beard and clutching a saw, which represented his role as the dispenser of justice. From at least the 4th dynasty of ancient Egypt, the Sun was worshipped as the god Ra, portrayed as a falcon-headed divinity surmounted by the solar disk, and surrounded by a serpent. In the New Empire period, the Sun became identified with the dung beetle, whose spherical ball of dung was identified with the Sun. In the form of the sun disk Aten, the Sun had a brief resurgence during the Amarna period when it again became the preeminent, if not only, divinity for the pharaoh Akhenaten. In Proto-Indo-European religion, the Sun was personified as the goddess Setu-ul. Derivatives of this goddess in Indo-European languages include the Old Norse Sol, Sanskrit Surya, Gaulish Solus, Lithuanian Saule, and Slavic Solunci. In ancient Greek religion, the sun deity was the male god Helios. But traces of an earlier female solar deity are preserved in Helen of Troy. In later times, Helios was syncretized with Apollo. In the Bible, mentions the Son of Righteousness, which some Christians have interpreted as a reference to the Messiah. In ancient Roman culture, Sunday was the day of the sun god. It was adopted as the Sabbath day by Christians who did not have a Jewish background. The symbol of light was a pagan device adopted by Christians, and perhaps the most important one that did not come from Jewish traditions. In paganism, the sun was the source of life, giving warmth and illumination to mankind. It was the center of a popular cult among Romans, who would stand at dawn to catch the first rays of sunshine as they prayed. The celebration of the winter solstice was part of the Roman cult of the unconquered sun. Christian churches were built with an orientation so that the congregation faced toward the sunrise in the east. Tonatiuh, the Aztec god of the sun, was usually depicted holding arrows and a shield and was closely associated with the practice of human sacrifice. The sun goddess Amaterasu is the most important deity in the Shinto religion, and she is believed to be the direct ancestor of all Japanese emperors. Characteristics. The Sun is a G-type main sequence star that comprises about 99.86% of the mass of the Solar System. The Sun has an absolute magnitude of plus 4.83, estimated to be brighter than about 85% of the stars in the Milky Way, most of which are red dwarfs. The Sun is a population I, or heavy element-rich, star. The formation of the Sunday may have been triggered by shock waves from one or more nearby supernovae. This is suggested by a high abundance of heavy elements in the Solar System, such as gold and uranium, relative to the abundances of these elements in so-called population II, heavy element-poor, stars. The heavy elements could most plausibly have been produced by endothermic nuclear reactions during a supernova, or by transmutation through neutron absorption within a massive second-generation star. The Sun is by far the brightest object in the Earth's sky, with an apparent magnitude of minus 26.74. This is about 13 billion times brighter than the next brightest star, Sirius, which has an apparent magnitude of minus 1.46. The mean distance of the Sun's center to Earth's center is approximately 1 astronomical unit, though the distance varies as Earth moves from perihelion in January to aphelion in July. At this average distance, light travels from the Sun's horizon to Earth's horizon in about 8 minutes and 19 seconds, while light from the closest points of the Sun and Earth takes about 2 seconds less. The energy of this sunlight supports almost all life on Earth by photosynthesis, and drives Earth's climate and weather. The Sun does not have a definite boundary, but its density decreases exponentially with increasing height above the photosphere. For the purpose of measurement, however, the Sun's radius is considered to be the distance from its center to the edge of the photosphere, the apparent visible surface of the Sun. By this measure, the Sun is a near-perfect sphere with an oblateness estimated at about 9 millionths, which means that its polar diameter differs from its equatorial diameter by only 10 kilometers. The tidal effect of the planets is weak, and does not significantly affect the shape of the Sun. The Sun rotates faster at its equator than at its poles. This differential rotation is caused by convective motion due to heat transport and the Coriolis force due to the Sun's rotation. In a frame of reference defined by the stars, the rotational period is approximately 25.6 days at the equator and 33.5 days at the poles. Viewed from Earth as it orbits the Sun, the apparent rotational period of the Sun at its equator is about 28 days. Sunlight. The solar constant is the amount of power that the Sun deposits per unit area that is directly exposed to sunlight. The solar constant is equal to approximately at a distance of 1 astronomical unit from the Sun. Sunlight on the surface of Earth is attenuated by Earth's atmosphere, so that less power arrives at the surface in clear conditions when the Sun is near the zenith. Sunlight at the top of Earth's atmosphere is composed of about 50% infrared light, 40% visible light, and 10% ultraviolet light. The atmosphere in particular filters out over 70% of solar ultraviolet, especially at the shorter wavelengths. Solar ultraviolet radiation ionizes Earth's day-side upper atmosphere, creating the electrically conducting ionosphere. The Sun's color is white, with a SAE color space index near, when viewed from space or when the Sun is high in the sky. While measuring all the photons emitted, the Sun is actually emitting more photons in the green portion of the spectrum than any other. When the Sun is low in the sky, Atmospheric scattering renders the Sun yellow, red, orange, or magenta. Despite its typical whiteness, most people mentally picture the Sun as yellow. The reasons for this are the subject of debate. The Sun is a G2V star, with G2 indicating its surface temperature of approximately 5778 K, and V that it, like most stars, is a main sequence star. The average luminance of the Sun is about 1.88 gigacandela per square meter, but as viewed through Earth's atmosphere, this is lowered to about 1.44 GCD/M2. However, the luminance is not constant across the disk of the Sun. Composition. The Sun is composed primarily of the chemical elements hydrogen and helium. They account for 74.9% and 23.8% of the mass of the Sun in the photosphere, respectively. All heavier elements, called metals in astronomy, account for less than 2% of the mass, with oxygen, carbon, neon, and iron being the most abundant. The Sun inherited its chemical composition from the interstellar medium out of which it formed. The hydrogen and helium in the Sun were produced by Big Bang nucleosynthesis, and the heavier elements were produced by stellar nucleosynthesis in generations of stars that completed their stellar evolution and returned their material to the interstellar medium before the formation of the Sun. The chemical composition of the photosphere is normally considered representative of the composition of the primordial solar system. However, since the Sun formed, some of the helium and heavy elements have gravitationally settled from the photosphere. Therefore, in today's photosphere the helium fraction is reduced, and the metallicity is only 84% of what it was in the protostellar phase. The protostellar Sun's composition is believed to have been 71.1% hydrogen, 27.4% helium, and 1.5% heavier elements. Today, nuclear fusion in the Sun's core has modified the composition by converting hydrogen into helium, so the innermost portion of the Sun is now roughly 60% helium, with the abundance of heavier elements unchanged. Because heat is transferred from the Sun's core by radiation rather than by convection, none of the fusion products from the core have risen to the photosphere. The reactive core zone of hydrogen burning, where hydrogen is converted into helium, is starting to surround an inner core of helium ash. This development will continue and will eventually cause the Sun to leave the main sequence, to become a red giant. The solar heavy element abundances described above are typically measured both using spectroscopy of the Sun's photosphere and by measuring abundances in meteorites that have never been heated to melting temperatures. These meteorites are thought to retain the composition of the protostellar Sun and are thus not affected by settling of heavy elements. The two methods generally agree well. Brought to you by WikiVidi Documentaries. Would you like to know more?